Now I'm going to show you how to do the pattern matching or template matching. This is the dumbest way to recognize anything. It is dumb because it takes a lot of computation time. And also it is dumb because if the scale is different, you're thrown off. If the image is rotated, you're thrown off. So it just works only for the case that you came up with. It's not generalizable. So it is a very dumb way of doing it, but for a given specific problem or given specific image, it is very effective. So I will show you how to use it. Essentially, what we are doing is that we actually tell the computer what pattern you're looking for. It's this exactly. The computer has no understanding of what it is, and it doesn't know about the scale or anything. It just dot per dot, it will remember those values. I will show you. So suppose you want to detect all this quarter rest symbol. What we do is that you just make one, and then imagine that you are taking this from one corner of the image to the other corner of the image, and you are moving it pixel by pixel to see how well it matches. How do you compute that it matches? Is that you subtract those two images. In this case, this is a binary image, so you have zeros and ones. So you can easily imagine here, if I put this on top of each other and I have this two-dimensional array and I'm subtracting the values of one image from the other, then if it really matches here, you would get 0. But if it didn't match here, then you would be subtracting ones and zeros that did not match. For example, this white image here, the entire image is ones, right? And this quarter note, there are some white part on the side, so which will subtract one from the background and one from this outside part. It would become 0. But when it comes to the inside part here, you're subtracting 0 from 1, so you would not get 0. So if it didn't match, then you would not get 0. When it matches, you will get 0. When the image is damaged like this, then it doesn't match well, but you can see it will get pretty close to 0 compared to these cases or these cases, and so on. Okay. Now it is essential that you include the white boundaries there. So otherwise, if you go to pitch black area like this, then you would get 0 because you're just subtracting the black part. But so you need to include the white part around, then you will see the score. So here, what we have to do is that do this computationally and using loop so that you can score them, how well they do, and also, and then see which part they had a good match. Wherever they had a good match is where this quarter rest note, the quarter rest was found. So you can apply the same thing to all kinds of notes, all kinds of symbols. You can have this clef here, and you can have the flat and sharp and all those, and it will show you there's naturals also. So this method is very powerful and very dumb. Powerful only under this context. If you have a different font, then you will see it fails completely. If it's different size image, it fails completely. So it's just very delicate and only works in one case type of thing. All right, let's see the computation of it.